Hello everyone, this is Manish from Skillable India, and in today's session we are going to learn about the most important topic in geometric dimensioning and tolerancing, which is nothing but datums. Okay, so in this particular session we will understand about datums and datum features, and I will also let you know that what is the difference between datums and the datum features. Okay, so in this starting of the session, first of all, we will understand that with the help of definition. So datums are nothing but the references. Okay. So as per the ASME Y 14.5 1994 standard, define datum as a theoretical exact point, plane and axis. Okay. So whenever we are talking about datums, so we are talking about the references. Datums are act as a references and they can be considered as a point, axis and plane. Okay, so that's why point, axis and plane. So that's why we are calling that theoretical. Okay, so these are the derived from the true geometric counterpart. Okay, so of a specified datum feature. So whenever we have a part and in that there are different features. Okay, let's say in a part there is a hole. Okay, so datum, that hole or the surface of the outer surface of that part is considered to be the datum feature. Okay, and that a datum is an origin from which the location or the geometric characteristic of a feature of a part are established. Okay, so I've already told you that datums are acting as a references. That's why we are taking an origin from which the location we are locating the part that are established, the geometric characteristic of the feature. Okay, in easy words, a datum serves as a reference entity for measuring and locating the different geometric feature of the part. Okay, so I will tell you with the help of example. So the datum symbol is compatible with all GD&T symbols. So the datum symbols, okay, either it's a primary datum, secondary datum, or tertiary datum. All datums are compatible with the GD&T symbols except for those related to the form tolerance. Okay, so we have already completed the form tolerance, which is straightness, flatness, circularity, and cylindricity. So in these four cases of form control, we do not provide the we do not provide datums. Okay, because in form control, we have already understand that they are independent of location, orientation, and the location and the orientation. Okay, so they are independent of it. So that's why we do not use the datums in the form control tolerances. Either it's a straightness or flatness or circularity or cylindricity. Okay, so let's say we will understand this thing with the help of example. So this is the example. Okay, so in this example you can see this is a part. So we want to manufacture the part. Okay, so we have to take a raw material. So this block we are using as a raw material. Okay, in this example I am taking this block as a raw material. Okay, so first of all we have to place it on the machine table. Okay, so first of all, if this is a raw material, so it's all the surfaces are uneven. Okay, so first of all what we will do is that the at least one surface we will make as a flat surface. Okay, to make that surface as a reference surface. Okay, or we can call it as a individual feature surface, or the first surface which is perfectly flat, which we can use as it as a datum. Okay, so we can choose any surface as the first surface. So in this case I am choosing this surface for machining, and we are keeping this onto the machine table and start machining onto the first surface. Okay, so then we are start machining. So the very first surface that we are going to machine does not have any relationship between any other surface. It is not dependent. Okay, so this first surface is not dependent on any surface. Okay, because this is the first surface, and first surface is always used as a primary datum surface. Okay, so that's why we call this first surface as a individual feature. Okay, because it do not have any relationship. So that's why the first surface we use, it uses as a, it called it as an individual feature. Okay, so after manufacturing that individual surface, the first surface or the feature, we take it as a reference. So the first surface, we take it as a reference and then we put it onto the machine table. So after machining the first surface, this surface will act as a reference surface, and this, taking reference of this surface, we are now machining onto the other surfaces of the part. Okay, so the rest it onto the machine table and then create a relationship with the second feature. Let's say if I am working on this part, let's say if I want to create a slot like this and I want to cut a slot, so I will use this surface as a reference surface, the bottom surface as a reference surface for machining onto the second surface. Okay, so this surface is having a relationship with the bottom surface. Okay, so to the first existing feature we do not have any relationship. Okay, so then start machining on the second feature. So how to create relationship to, that with the second feature and the individual feature, already accurate existing accurate feature which we have already machined at the below surface, is called datum. Okay, so the bottom surface which we are using as a reference, okay, so that surface is act as a datum. Okay, so in this in this case you can see that the bottom surface is acting as a datum. Okay, so this is a datum feature. Whenever we are this surface is there, whenever we can touch the surface or we can touch the reference, it is considered to be the datum feature. Okay, so this is a tangible one. So datum features are the tangible or the physical features, whereas datums are the theoretical one and they are intangible. Okay, although I will give you a brief introduction, brief discussion about this. Okay, so datum is the theoretical one. It could be a line, it could be a edge, it could be a plane. Okay, or datum feature can be a surface. Okay, so in drawing we represent datum features like this. Okay, so you can see that this surface we are using as a primary datum in this case. Okay, so this is the symbol of primary datum and this is how we provide the relationship. Okay, so we will move on to the presentation. Okay, so in drawing, we represent the symbol like this. Okay, so A under the box and this is having line like this. Okay, so this is the datum feature symbol. This is how we provide the datum feature symbol. We can accept any symbol from A to Z. Okay, except IOU. This triangle can be a filled triangle. Okay, and it can or it can be an empty triangle also, or the open triangle. Okay, so it can be a filled one and the open one also. So the datums are nothing but the creating a relationship between intersect feature and the already existing accurate feature. Okay, so basically it is a relationship between the second feature and the already accurate feature, which is the bottom surface of the part. Okay, or the feature or the feature of size. Okay, so datums are the basically the references and the relationship between the second feature and the individual feature. So how we are going to represent it onto the datum feature control frame. Okay, so feature control frame. So this is the example of a feature control frame. So this is feature control frame. In this feature control frame, third compartment, fourth compartment, and fifth compartment is given for the datums. Okay, so this is given for the datums. Now, in the first compartment, in the third compartment, this is the third compartment, this is the fourth compartment, and this is the fifth compartment. Okay, so in third compartment, there is always be a primary datum. In the second compartment, we always have a secondary datum. And in third compartment, we always have a tertiary datum. Okay. So how we give in to the feature control frame? let's say the order, let's say A, B and C, how we give is called the order of precedence. Okay. In what will be in the third compartment, fourth compartment, and fifth compartment, it will be a called as order of precedence. Okay. So order of precedence is very, very important topic. We will cover it this in a very detailed manner. Whatever we take into the third and fourth and fifth compartment. Okay. In this case, whatever we are taking it into the third compartment, let's say in the third compartment we are taking B, fourth we are taking A, and third fifth compartment we are taking C. Okay, so this will be the primary datum, this will be the secondary datum, and this will be the tertiary datum. Okay, so this order is very important. Whatever we are using, let's say we are using C over here and B over here. Okay, so this order of precedence is very important. This is why it is important. Why? Because it is whenever we are giving onto the engineering drawing, so when the time of inspection, these datums plays an important role. So okay, so it controls the 6 degrees of freedom, although we will cover that 6 degrees of freedom in a different session. Okay, so this six, with the help of 6 degrees of freedom, we make the part stable in a stable condition. Okay, so the primary datum, secondary datum, and tertiary datum basically locks the part onto the table. Okay, and do not and all the movements of the part with the help of locking all 6 degrees of freedom in this. So this order of precedence is very, very important in the feature control frame. So we can give any ACB, ABC, BCA. Okay. So we will know today how to choose. We will also know that how to choose the order of precedence sequence and why we take it as a why it is important in taking as a datum. Okay. So whenever we are going to discuss about the datum reference frame, in that we will be discussing this topic. Now, the concept of datum. Okay. So I have already told you this thing that first we take the raw material, which I have already told you. Whenever we will take a raw material to manufacture the part, first surface. Okay. So let's say this is the first surface, the top surface we are considering of the raw material is the first surface. So this surface, the first surface is also called the individual surface, individual feature. Okay. So this surface is also called the individual feature. And we start machining does not require any relation with the other surfaces of the raw material. So the first surface do not require any relationship with the other surfaces. Okay. And of the raw material. So we can start machining with the first surface. Then if we are machining onto the next surface, let's say second surface. So the first individual feature, the top feature will act it as a datum feature. So this surface will be act as a datum feature. Okay, this individual feature will be act as a datum feature and it will create a relationship between this. Okay, this will act as a reference. So this will act as a reference surface. Okay. Now we will understand in very detailed manner that how it is important that datums and what is the difference between the datums and the datum features. Okay. So as I have already told you about the datums and the datum features, it is very confusing between the datums and datum features. Okay. Just remember that when we are talking about datum features, we are talking about a physical form or we can touch that feature. Okay. Or it is a tangible form. Okay. So first of all, it is a common mistake. One must be clear about both to make a professional engineering drawing. Okay. So you must, as a design engineer, you must be very clear about this. So a datum feature is a physical tangible feature of a part. Okay. So let's say this is a part and this is a surface. Okay. And this surface is acting as a reference. So this is a datum feature. This is acting as a datum feature. Okay. So that establishes the datum because this surface is acting as a I will say as a reference feature. Okay. Since it is a real entity, so this surface is a real entity. We can touch this. It is not exact and can have an irregular form. Okay. So this surface obviously can have an irregular form. Okay. So whenever we are taking it as a reference, so there is a chance that we may end up creating wrong decisions. Okay. Wrong inspection. So for this, we create a plane, which is a theoretical one, which is touching the high points of this surface. Okay. So let's say if this is a part, okay, so we will create one imaginary plane which is touching the high point. Okay, so this plane at the bottom, this plane at the bottom will act as a datum, and this plane is a theoretical one. Theoretical. Okay, so planes, the datums is a relatively more abstract concept. Okay, it is a geometrical exact representation of the datum features. Okay, so whatever datum features are there, let's say its surface is a datum feature, but we want exact dimension. So we will create one plane which is touching the high points of this part. That's how we can calculate the right inspection. Okay, whether it's a 5 mm. In this case, let's say we are taking, so whatever measuring with the high points with the imaginary plane, it is touching the high points of the part. Okay, so this is a theoretical one. This is intangible. Okay, so we cannot touch this plane. And so that the example, if a rough surface of is the datum feature, so in this case I have shown you that this is a rough surface of the datum feature. The datum will be perfectly smooth plane. Okay, so I have created the plane bottom of this part that best simulates the surface. Okay, so this is the how we can create the differentiate between the datum features and datums. Okay, so datums can be a point, it can be an axis, it can be a plane. Okay, so these all considered to be a datums. Okay, so this is all about the datums and the datum features. In the next session, we are going to cover about the datum reference frame and the order of precedence. So thank you. Thanks a lot.